Let us begin with a question. When a light of wavelength lambda strikes a metal surface, the kinetic energy of the photoelectrons emitted will be 1 electron volt. When a light of wavelength lambda strikes a metal surface, the kinetic energy of the photoelectron emitted will be equal to 1 electron volt. And when a light of wavelength lambda 3 strikes the metal surface, the kinetic energy will be equal to 4 electron volts. What is the work function value? What is the work function value? Work function is equal to how much? This is the question. When a light of wavelength lambda strikes the metal surface, the kinetic energy of the photoelectrons emitted will be 1 electron volt. When a light of wavelength lambda 3 strikes a metal surface, the kinetic energy of the photoelectrons emitted will be equal to 4 electron volts. What is the work function value? So what is the mathematical relation? What is the mathematical relationship of the photoelectric effect? Kinetic energy is equal to E minus W. So what is the first equation? When E is equal to Hc by lambda minus W is equal to 1 electron volt. This Hc by lambda stands for energy of the photon, and W is the work function, and this is the kinetic energy. When Hc by lambda by 3 strike the W will be equal to 1 electron volt. This is the equation 2. This is the equation 1. This will be 4 electron volts. Now subtracting equation 1 from equation 2, what will be the value? 2 Hc by lambda will be equal to 3 electron volts. Implies energy of the photon is equal to 1.5 electron volts. Then what will be the work function? E minus kinetic energy. What is the E value? 1.5. And what is the kinetic energy? 1 electron volt. So work function value is 0.5 electron volts. Right? Coming again, what is the point? When light of wavelength lambda strikes the metal surface, what is the kinetic energy of the photoelectron? 1 electron volt. When light of wavelength lambda by 3 strikes, what is the kinetic energy? 4 electron volts. What is the relation? Kinetic energy is equal to energy of the photon minus work function. So we have generated two equations. Solving these two equations, we got the E value as 1.5 electron volts. From that, the work function is calculated to be 0.5 electron volts. Now, next question is, what are the important relations we have discussed regarding the Bose model of an atom? So getting back to that, Rn is equal to R1 into n square by z. En is equal to E1 into z square by n square. Vn is equal to V1 into z by n. What is R1 stands for? Radius of the first orbit in hydrogen atom. What is E1 stands for? Energy of the electron in the first orbit of the hydrogen. And what is V1 stands for? Velocity of the electron in the first orbit of the hydrogen atom. What are these some more relations? If the total energy of the electron is represented as minus E, and potential energy will be equal to minus 2E, and kinetic energy will be equal to plus E. So total energy is given by minus E square by R minus of E square by R of E square by R. Then what will be the potential energy? Minus E square by R. What is the kinetic energy? Plus of E square by R. In terms of Rydberg constant, what will be the total energy? Minus RHC into Z square by N square. And what will be the potential energy? Minus 2RHC into Z square by N square. And what will be the kinetic energy? RHC into Z square by N square, where R stands for Rydberg constant. These are the important formulae which we need to remember.